Okay, so a task queue, we can use a task queue to do these background tasks. So the idea is that our request takes too long. Even if it does finish, if it manages to succeed, and it won't for a large enough account, but even if it did, it takes too long, the user will get frustrated sitting there waiting. So instead what we want to do is we want to make it so that instead of doing all the work inside the request, we will say, create a task that will have all the work we're going to do, and throw it into a queue to be done in the background, and then immediately return, okay? And then there'll be a separate instance, or it could be the same instance, or whatever, that is going to grab data off that queue and do the task, all right? We understand the idea here?
So like asynchronous task in Android.
Yeah, it's something done
UI.
in a different, as a background task, right? And so that's the idea of the queue. And so what we have is our request. So this is like the slash GitHub -info. And that we're going to add to a queue a task. Get stats or whatever you call it. And then there's a process back here which will pull that off and do the work. Okay, so these will make all the API.GitHub requests. Okay. Okay, so that's the idea. I'm going to go to GitHub.info. I'm going to enqueue a task and then immediately finish, right? And so I'll draw my HTML. And so it's not going to wait for it to finish the task. It's just going to queue the task and keep going. So with this model, what are we going to need to do to change our application to make it work with this new model?
Just going to take a username and stick it on the queue, and then the queue will call an endpoint with that username.
Yeah, so this queue needs to have all the data necessary for task, okay, in general. And so that's going to mean the access token,
Well, the token can't pull on a session database.
username, etc. Okay. So it needs all that. That's definitely one piece we're going to have to do. What if I go do all this work? What happens to the thing I calculate, stats?
You're going to store it in the data store so that it can
Right.
be shown on the next request.
In its current form, we just dump it right to the page. But we can't do that anymore because this is not running as a request. It's running in a background process. And so we don't have a request to send HTML to anymore. So what we need to do is make this guy, in addition to doing all this back and forth API with GitHub stuff, it needs to write to data store, okay? The results, right? So that I can get them later from here, right? And so, if we have the data store over here, that's going to write to that, and then I'm going to get that from over here. So the HTML here will get it from over there, okay? So now what we're going to do is we're going to cause a task to happen. That task is going to go do stuff. Eventually, it's going to write to the data store. And now, instead of dumping it right to the page, we're going to pull that data out of the data store. Okay? Does that make sense? So I think instead of when you go to /GitHub-info, it's not actually going to enqueue this task. We'll do this once when you log in. So we're going to, we're not going to do that here. We're going to do that on login. And instead, we're just going to always, if you refresh on GitHub-info, we'll just always pull out of the data store. Okay. So now we have a model that's like the mint.com model. I don't ever see the results of my request. The request is always happening in the background, all the API stuff, when it's going to query the information from my bank and stuff. I only see the most recent version. I see the transactions they have stored in the mint.com database, not in my bank. So they have this asynchronous process which goes and populates that list. And that's what I'm always viewing, is that list. Okay? So this is the model we're going to switch to.
It's kind of a question, like in terms of operations, from a perspective like mint.com, that's got to be like a ton of processing, a ton of bandwidth.
Yeah. I'm sure it's a staggering amount of machines churning all the processes in the background. Though the model is very similar to what we're talking about here. they have a big queue or lots of queues, and they have a whole lot of machines pulling jobs off the queue. Each one will do a job, and then they'll get to the next job, and the next job, and the next job. Imagine you have a giant room full of people on the phone, right? And you have these people, you want them to contact your clients, you have 1,000 clients. They each just take one at a time and work on it, right? And that scales, you just add more people to the call center, and now you can handle thousands of customers, or 1 million customers, right? It's the same idea with the computers. It's the model we're thinking about. This model scales because I just need more workers, okay? Churning away on getting the stats. It didn't scale so well, the first model, because a single request just couldn't handle the load we needed to throw at it, okay? But with this, I could have lots of machines. And in fact, we could break our task up into multiple pieces. So rather than do this all in one task, we could cut up our task into separate tasks. In other words, get the stats for this repository, okay? And then we can break it up into, if I have, say, 20 repositories, 20 separate tasks, instead of one task that does all 20, okay? So we could also do it that way, if we wanted to. And that would just be, instead of queuing one task, we can queue 20, but the same basic idea. The challenge if we did it that way is updating the data source a little trickier, okay? Because now I'm doing work all on the same entry, right? So if we went that route, rather than storing the stats per user, we'd store the stats per, say, repository, and then when we view it, add them up then, okay? But I think we just want to do it all as one task, and it'd be easier, okay? So let's try to build that if we can. So we need to learn how to enqueue things into the task queue. In Go, this turns out to be really easy. There is this documentation about push queues and stuff. This is what a push queue is. The pull queue is a little different. But with a push queue, you can enqueue tasks, give them name, and give them parameters and stuff.
Push queue just means you're pushing it onto the queue as opposed to its program hold stuff on.
Yeah, the idea here is that they are automatically handling this instance, which is pulling the work off. You can make your own system that can pull the work off and do it that way, and that's when you use pull queue. So then you're enqueuing work, but it's not getting done. You're making the thing that will get the work done. Okay? And it's giving you a queue, basically. But for push, we have to know. So we can use that API. There's an API to do all that work. But there's an easier API for Go that we can use instead. It's in our way. Okay, and it's called delay. So, app engine docs go task queue delay, the delay package. So the delay package, you import it like that, provides a way to execute code outside the scope of a user request by using the task queue API. And it has a kind of funny way you build it, but it's actually a lot easier than having to use the task queue. Basically, the idea is you say delay.fun, give it the name you'd like to give the name of the function, and then the actual implementation of the function. And it, when you do later, when you say, so you created this function, this is like a delayed function. Later, if you call it, if you say laterfunc.call, it will it'll add a task to the task queue that will execute whatever you put inside the function definition here. Okay? Are we following the process? So I create a delayed function, and then I later call that delayed function. And whatever code I put inside of the function definition is executed as part of the task. So the code inside here doesn't execute as part of a request. It happens in the background. Okay? And it could be on a different computer. Not necessarily the same machine. It could be a different machine. And so the importance there is, if I want to reference data, it either needs to be global data like the constants I use, or it needs to be data that I pass in. So the data here is something. This is passed into the call of the function. The something here will become x over here. Okay? So in general, it's pretty easy. You just pass in the data you want it to be inside of here, and you'll be good to go. Okay?
That won't get it to the machine, though, right?
May
Right, but if it gets called for a different machine, then the stuff you call it with, or the data that's used in the function needs to be in the memcache in the data store, right?
No, it's passed along with it. It uses gob, G-O-B,
Yeah, that's slick.
gob, which is like JSON but just for Go, and so it's an encoding. So it serializes this into binary data and passes it with the task. So
I don't think the Python API has that set up. That's pretty slick.
So I think we can use that to create our background task. So there's a bunch of steps we have to go through, and hopefully we can remember to do all of them. Okay. So I think we need to create a new function up here, and we'll call it var delayed. What do we call this thing? Let's call it delayed get stats. Okay. And this was going to be a delay.func. I think that's the interface.
Now you said this user token, does that change every login, or does that expire after some time? The GitHub user token?
This token?
Yes.
It does expire after about an hour. But let's not worry about that for now. That's a different problem. So func init and delayed get stats is a delay dot func. You give it the key. What did it just do? The key here, I think you can do anything you want. It just has to match down below. Call it delay get stats. And then you pass in a function. And the first thing the function takes is a context. This is like the app engine context we saw before. Right? So now this will be enough for me to get my API stuff done. What else do I need as far as my API goes? So that's a context. I need an access token and a username. So that's what the other things we'll pass in here. Access token, username string. And so down in here, what I want to do, we can make this return an error. And it should account for that appropriately and do nice things for us. So all we want to do here is say return. Well, first we want to create the API. So we'll say API GitHub API. The context is context, and access token is access token. Username is username. And then here we just say API dot get commit summary stats. I guess we need to pass that in too, don't we? Let's just hard code it here, since it was just hard coded in the other place. So that gives us our stats and possibly an error. So if there's an error, we'll just return that. And then to do insert into data store, we need to do that. But otherwise, we're just going to return it. Okay. Cannot use delay func. It's a pointer. Right, I didn't use it, so I guess we can. I don't know what it'll do if we do info F. Let's find out. Stats. So what I did is I basically took the definition we had in login and put it in here. I'm doing all the same stuff. And eventually we'll insert that into the data store. But for now, we'll just kick it off as a task. So in my login, instead of doing this, what we're going to do is in here, before we redirect to a login, that's when we'll kick off the delay task. So as soon as I log in, I'll go do the task to go get the GitHub info. And so the way we do that is we say delayed get stats.call. Okay? You give it the context and arguments. And so the arguments are, if we look back in the GitHub, we called them access token and username. And so that's what we pass here, access token and username. Okay? Cool. now, instead of doing this here, so we don't need that, that or that, or that, or that. So we need to, two things we're going to need to do. We're going to need to put the stats into the data store and get them back out. But for now, what we have done is we've made it, as soon as I log in, we'll start as a background task the getting stats for a user. Okay? So let's see what happens if I run this. Localhost 8080, I say login with GitHub. I deleted my application so I can add more things. Oh, I don't know my password. Okay, let's just not do that. We'll just look at one. Okay, so now it finished immediately, right? Because GitHub Info no longer waits to do all this work, but in the background we have a task running, which may be easier to see if we see it's doing its thing. So this is running from a background task, which I think we can see in here. About one task in the default queue. So it's running this task, I think. Yeah. And so it's just continuing to run this task. And you could see if you had other tasks, you'd see them in here. If we look back here, what it's done is it creates a default queue, and that's this queue. You can make other queues if you want. But this one has a maximum of 5 per second, and it would just turn away. So you could add more tasks and it would turn away at it would run up to 5 per second or whatever. And it's just gonna keep going until it finishes.
Still cool.
Yeah, it's pretty easy to use. I mean, this is a little weird to get used to.
Yeah, the syntax is a little funny on me. Can we just talk through that again, like the entire later font, delay font?
Yeah, let me break this up a little.
So it says, I'm just looking at the docs, it says delay font, delay.func, and it takes a key and then a function. What's the key?
I think that has something to do with what's shown up in here somewhere, but I don't know what it matters because you don't actually use it for anything.
What did we pass it for a key? What did you pass it for a key?
It says, I just made up a name. I called it delayed whatever.
Oh, so
delayed stats.
maybe it's just the name of the process. Makes sense.
It doesn't tell you what the key is for. It's like the second argument.
Is what you found out as a key showing up in the console?
It doesn't seem to, but maybe in the real console it would.
Is the key task 1?
Well, now it's done. It finished. So. But anyway, it's just something you make up. And so this finished. So the post here finished, and it took a while to finish, but it eventually got stats 14. So we just need to insert that into the data store. Okay. So how do we do that? Okay. So you wanted to walk through this code. Right. So that's a key. You make it up. Then you give it a function. Now it says in the docs it says interface. And the reason it is because this function can look like a lot of things. It's up to you to define the function. The function has to take as its first argument the context. But the things after it are the things you can use with call. So you take the context and then access token and username. That's what we took. And then it can return an error. Okay? And so we're creating a new function, and this is the definition of the function. Create an API, create the since, which is 30 days ago, and then call get commit summary stats. And then we need to do the data store insert, but for now we're just returning it. Okay.
And then, go ahead.
Well, I was just going to say we create the API using the parameters that were passed into us.
Yeah. And then right above that, like line 18 or something, you declare, bar delay.
Yeah, I did this so that I could use it in the other. So the idea here is that I can't just invoke a regular function. I can't just say delay get stats parentheses, because that would do it immediately. And I don't want to use a go routine, though I could, because I want to use the task queue. Because I might have 100 background workers, and I want to send it to one of them. So I don't want to use a go routine, because a go routine would only be for the current process. So instead of a go routine, what I want to do is create a function that when called, and call is just a thing we used on the other side, instead of like running this code immediately, it creates a task that will run this code.
I guess the place where I'm a little confused is your variable's delayed get stats, and then your key on 22 is also delayed get stats. But those are two different things.
Yeah.
And you could have called 22, my favorite dog or whatever.
That's right. That's fine.
And then to invoke the function, you use the later func dot call or.
Right. So we've saved this here. So this is a function we created, ready to be called.
Okay.
But we haven't called it yet. We call it over on here as soon as we log in. After we've got the username and we set the session, we say delayedgetstats.call.
And that just sends it off running.
Yeah, and it queues a new
Puts it in
task.
the queue.
Yep. And it will give it with this data so that when it's run, it can get the data.
Thank you very much.
Yeah. And so that's the general, like I said, it's a little weird, but it is actually a lot smaller than if you did it manually.
It's not that much. I mean, it's very little code.
Yeah, and it's just, it's like passing around the function pointer, and that's kind of weird. But actually what it does is, well, it's yeah.
So in actual production for this particular example, you probably use channels. You have like a loading page or whatever that you could actually immediately serve, and then you use channels to actually get the data altogether.
Yeah, app engine channels.
App engine channels.
Yeah, and then from the task you can send to the channel, that'll go back somehow to the Google channel server, which will then signal to the client, and they'll get their data. So that's kind of an
And
interesting.
just pop it up with Ajax.
Yeah, so now you're like going through like 4 systems to get back to the client. But it would work, it would totally work to do that. And that probably is a good model for certain kinds of tasks. Okay, so we need to add the data store. That should be pretty easy. I can't even remember anymore. Data store.put. We have to create the key first. New key, and it takes the context, the key name, or no, the entity type, which is going to be it's called stats. The key is going to be username, and then nothing for that one, and nil. And then, so this is going to be stats for a particular user, so that's why we use the username as a key. And then we do the context. Is it context, and then the key, and then the entity? And the entity is the stats. Oh yes, that would break. That can return an error. And the key, which we don't care about. That actually apparently worked. Okay, so we create a key. Key will be the stats and the username, just because it's a different kind, and then we store the stats under the username. So let's see if that works. So we've inserted it into data store. So in order to see if this works, I have to re-log in, because that's the only place it actually happens. So log in again. Now it should be kicking off this task. Cool, got a task. We can see it churning away in here. When it finishes, it should write to the data store with a new kind. So let's see if we can find that. Kind will be stats.
You show the data store code again while it's running. So we've got data store new key. And it's not a new incomplete key since you're given a username.
Yep, that will be the key.
And if it's new incomplete, it'd come up with some sort of an identifier. You just leave those blank. And then we have data store put, and we give it a key, and then put the stats. Cool.
Oh no. Something bad happened.
Oh my gosh,
it looked like there was an error, but it's still going.
It exits on here, so.
I don't know what that was about.
There's this whole thing on.
It seems kind of odd, right? I don't know what happened there. It's still going. That's code from the commit. I guess it shows some part of the commit when you do the git commit.
Maybe we weren't just watching it closely before to see it.
I think it's retrying the task.
Oh, you think it's retrying?
Yeah, it's retrying the task.
So that delayed job just is keep you trying.
It's starting over again.
We can't see the
So it
error.
finally did error out.
Well, no, this is the error because I control-C'd it.
Oh, you better do stuff.
Well, maybe we can get the error in here somehow. Oh, I just killed the server. Great. That's probably not going to work then. It's stuck. Not stuck anymore. Okay. Let me, let's make two changes just to get this going quicker here. One is I'm going to comment out the logging of the intermediate state here. So let's just comment that out, okay? Because that's what was filling up all the space. The second is that I think we can do this in a Go routine, okay, to improve the performance here. So the way we're doing these loops here, we can improve this. It's the listing of the commits, which takes a while, because there's a small number of repos. Sorry, there's a small number of organizations. We get the list of all the repos, that doesn't take too long, but it's each time we have to get the commits, it's taking a while. So let's do a Go routine here. And the way we'll do that is there's a couple ways we can do this. Let's call this. So we will. Make a channel. And we need to pass the organization in the repository. Let's do it this way. Okay, so we're going to have this repository channel, and we're going to for repo range repository channel. We'll do this for each one. So this will be repo.organization. This will be repo.repository.
I think that we need to do a remake of that old movie Repo Man. Now that you know Repo's got a different meaning. Be about a guy that steals your GitHub
this is going to be an issue? Why is this a problem?
Because there could be a race.
So we need another channel. Actually, we just do CS. Okay. So they'll push onto this, and then we'll make something else that pulls them out. So actually, we're going to do this in a loop. Let's have 10 of them going. So we'll do up to 10 requests to GitHub at a time, and then we will. Okay. So those guys are churning away. So here we say, so we push a new repo onto there, and it'll go do the work for it. Right, it'll go call this. And there's 10 of them, so we could do up to 10 of those at a time. And then we have to pull out of the, so let's call this CS stats channel. Stats dot additions plus equal CS dot additions deletions plus equal. Okay. There's something we're missing here. So we need a wait group. We need to add to it here. Something like this. That'll kill this guy. And so we just have to say, maybe this will work. Let's see. This I think has to go in a go routine. We can't return it, so we'll have to log it. What's it done like?
CTX.
App, okay. Is there somewhere else I'm doing that? Yep. This stats channel got to get closed somewhere. I think actually we can do it this way. Let's see if that works. I gotta relog in. Something. Send on closed channel. So something's wrong here. Oh, put that in the wrong. got one. So. I suppose I should add some context to the. It's hard to see what it's doing because we took those out. But it's doing work. We're logging them here, but we don't log the repo information. I'm trying to think through if I'm making this not finished, and it should be. Okay, so we create a wait group. We add one each time in this loop, and then we loop over the repository channel, and then, yeah, at the end of this function, we signal done. Okay, and then we start this guy, and what he does is he loops through every organization and every repository and pushes it onto that channel, and then he finally closes the repository channel. Okay, so the idea here is that I'm pushing a bunch of work into the channel, and then I have these tasks pulling it off. Okay, and each one will do one repo at a time, and then when we're all done, we close this channel. Yep. Okay, that was the idea. We wait for those all to finish. When they're all done, we close the stats channel, which causes this loop to finish, which we can then return the stats. Okay, so this way we're only adding these one at a time by using it this way. I forgot to close, so we will just sit there forever. So our task probably never finished. It's still going, waiting, it'll wait forever. So maybe we can see if we can kill a task though. So let's see what happens if I do that. I have no idea what happens if you delete the task while it's running. It may not be able to handle that properly.
So it hasn't.
So let's see if we can get this to go again. We may have to kill the server again.
I don't even look at the task queue.
It doesn't seem to be doing anything.
Doing something.
So you think there is it in here? Well, it's probably gone now, right?
Yeah, it's going in.
Okay. The dev server, doesn't have as many capabilities as the real server, so like killing a task and stuff doesn't always work reliably. Okay, so now is it turning? Yes, it's doing something. It's kind of doing multiple at once, but it's still pretty slow.
Okay, maybe rate limiting us.
Something like that, yeah. So adding this may not help.
Throttling us, rather.
So you got one.
Slightly faster.
Oh. Something bad happened. Invalid context should be created with the cloud context. What?
New cloud context for the test queue? I don't think so.
This is the wrong data store. Always check your inputs, I guess. How's that for confusing? That's why I was failing. This is the wrong data store. So it's
Curse you go imports.
huh?
Curse you go imports.
Yeah, well. better than typing them out every time. There it goes again. I was really hoping to make them do 10 at once would make it faster, but it doesn't seem to have made any difference.
It's faster. Or not 10 times as fast.
But this is why you run it in a queue, right? I mean, this is why we're doing it. It's just, it's annoying that it takes so long.
I think you got one commit. No, I think you got one commit.
Okay, it did finish. That's good.
And if you've got one commit, the raise condition on the counts isn't that big a deal.
Sorry, what?
I think you've got one commit, and if you've got one commit, the raise condition on the counters isn't that big a deal.
One commit?
You made one commit to the repository.
From the data store then?
I'm not getting it, so we need to add that. But
We can look at the data store now to see if it actually fills it.
so to get the stats, we make the key. It's stats. It's the username, so we got to get that out of session.
We're at time because it's simple. It wasn't go to
CTX request session.username 0 nil. And we do data store dot get. Give it the context key ampersand stats. Okay, so that should fill our stats now from the data store. Maybe. Oh, it was good. Oh, same problem. I should fix that. Okay. 14. So it did actually work. It did actually fill it in, and it did it. So this request is fast now, right? Because it's happening immediately. It's pulling from the data store. The actual work of filling in all that information is done in the task, right? And so that's what we've done, okay? So that's how you use a task queue. The second part of a task queue is you can schedule tasks, and that's done using, down here, configuration, schedule tasks. There's a YAML file you can add. Anybody heard of cron? So cron is like a Unix thing. It lets you schedule tasks on your computer to get run in a certain schedule. And this is basically what we're doing here. So this cron.yaml file, like our app YAML, will be the same folder. The syntax is you say cron and you give it the stuff, right? And so we could give it this URL and schedule every 24 hours. So where does it say that? Specifies a URL that will be invoked by the cron service. Okay. So the idea is that there's a service, this cron service running that reads your schedule. Every 24 hours, it's going to make a request to that endpoint, to /task/summary or whatever. You can call it whatever you want. I can make it to /. I can make it to a user's endpoint. And then whatever that request does, you could queue tasks into the task queue. You could just make a GET request to some URL. You could do whatever you want. Okay. And that would be done as part of that. Okay. Does everybody understand the idea here? So it's as if I have a person who has an alarm clock set for a certain time every day, and the alarm happens, and they go to their browser and they type in this URL and hit enter. Okay. That's what we've essentially done. This is what the cron YAML lets you do. And using that, you can schedule tasks. So it would be add to your schedule something you want to happen all the time, create an endpoint which queues the work to do, and then you're done. Okay.
Are you able to restrict that to only being started by the app YAML?
Yeah, that's a good question, and you're absolutely thinking the right direction, because otherwise people could start tasks. So you say secure client as just normal handler. You can restrict by adding login admin. That'd be the easy way to do it. So just add login admin to the URL. But I think it also passes something like this. So you can look at the headers of the request, and if the header has xappengine-cron true, then it came from cron, and you can use it. Users could try to add this, and it would strip it out. So you know that if it has this header, that it came from cron. And so the first thing you do in your, you'd either do login admin through the app YAML, or you would look at the request and say, request.header.get x-app-cron true, okay? So maybe we can just make a real, I'm not going to make it do this delayed task, but we can just make a fake handler here. So let me add a new scheduled.go package on it, and we'll do schedule-example. So and let's just log. I was scheduled. Okay, and so I just added a new endpoint, and if I go to /schedule example, we'll call this function. Give the context, and we're just going to log I was scheduled. So let's see if that works. What am I doing from package here? Don't see anything here, but we see it here. I was scheduled. The extra came because I passed it. That's not necessary. Okay. So it was called. So we need to make it so that I can't do that, because I want the cron service is the only one to be able to do that. So I don't want users to be able to do what I just did. I want to restrict that, right? And so we can do that by saying rec.header.get. The key is from this docs, right? So let's make sure I get that right. This accent engine cron. True. So let's add that. Not equal true. Is it 403?
403 is forbidden. Or which key status is forbidden.
Or you get with the header not set at all. Just check for no first.
Shouldn't have to.
It would be an empty string otherwise.
It'd be the empty string.
Straight, okay. Straight, not dual true.
Forbidden. So now users can't use the schedule example endpoint. So maybe a good strategy is if you want to have a scheduled cron, you might have /cron /schedule example, or something that's unique on your site, so it's unlikely to. Maybe you follow the app engine thing and do _cron or something. But this is fun. So now we want to be able to schedule this, and we have to add a cron YAML to our file, to our project. So we say cron.yaml, and we'll just copy the example they have here. Though we'll change the time period because we don't want to wait 24 hours. So that's ridiculous.
Every 1 minute.
Okay. So cron, colon, and then dash, this means a list, and then these are the object properties. Description, daily summary. Okay, we go to /. What do I put here?
Underscore cron.
Schedule. Dash example. And then every 24 hours, we don't want to do that.
Every 1 minute.
It says it supports every number, hours, mins, or minutes. Oh, that's interesting, from time to time. So you can actually do that too. But let's just do every 1 minute. Every 1 minute. So every minute it should hit this endpoint. I don't know if it's going to pick that up.
I don't think it checks for the minute. I don't think it should.
Does it even work locally?
Should.
Your login's not going to expire, like Rusty said, for your GitHub.
Well, that's not on this, but on the sample, but the login to get the key, Caleb, it can't be run headless because it keeps asking you to add the rest rest of your organization. So is that going to fail if that runs on a cron job? Because it redirects you to that.
Sorry, what?
The auth for the real background job, and it's displaying a page to the user. I mean, if the authentication changes, which yours is still going to ask you for organizations every single time because you haven't authorized all of them. So is that going to fail when it runs tomorrow night to generate your
We haven't
edition?
scheduled that. And yeah,
Well, I
it
know,
failed because
but-
the access token doesn't last forever.
Right, so that one can't run on a cron. I mean, it'll fail on a cron if the
When using Go, dev apps or view cron jobs, doesn't automatically run them. Oh, well, there, that's why it's not working. So cron jobs, but it lists them. There it is.
run now.
In production, this would run at these times.
So there you go. It would run them. And so when it's run, it would run the code. So, but it's just like a request, okay? So to answer your question about the access tokens expire, you have to use a refresh token, okay? So as part of when we swapped the tokens and got the access token, you can get a refresh token. In order to do so, you have to request offline access from the user.
Okay, so that happens.
So you'd add it to your scopes and stuff, and
Excellent.
you get the different token. What you would do is, as part of the access token, you'd see, is it expired? If it is, get a new access token using the refresh token, and then you'd use that access token to make the. So in your database, you would store the access token and the refresh token for each user. And even then, sometimes the refresh token will expire for other reasons. And
Sure.
so every once in a while, you're going to have to ask the user for the token again for security reasons. And at any time, somebody on GitHub can revoke the token.
Right.
So they can go into their settings and say, I don't want this access anymore. And then you have to account for the fact that your script will eventually stop working, and you need to somehow inform people that, hey, my script's broken.
Right.
So it is a little more complicated that way. So any questions about this? So yeah, if we want to do background work, if we have to do something that can't fit in a single request, we would use a task queue. So we looked at that. The other reason why we use the task queue is because it allows us to do requests that were not, allows us to do work that's not the result of a request. Okay, so I can do non-user initiated things using a cron. Okay, and the cron will by schedule, every day or something, run whatever I tell it to run. Okay, and so using the two together, I can say schedule every day, hit this URL, and then in that URL, start a task. And that's a very common pattern. And so if you have a summary roll-up process that happens every day, you would add to your cron YAML every 1 hour or every 24 hours run this, and then that URL would start a task that would actually do all the summary work. So it's a little complicated, but it gets you there. And it works around one of the big limitations of App Engine of the 60-second issue rate. But it turns out by doing so, it forces you to use a model which actually works better for other things as well anyway. So, cool. Yeah, so the idea of a work queue is a very general idea. We use work queues for lots of things, and that's how you do it with App Engine, using a task queue. Any questions about anything?
Push it on up.